Hi everyone, this is Dr. Shashi K. Pathak from National Institute of Education. Welcome back to my How to Learn series of short videos. In this video, we will understand and learn how to derive a quadratic equation formula using a quadratic equation which is defined here as ax squared plus bx plus c equal to 0. So what I'm going to do, I'm going to divide the left hand side by a here first. The right hand side should be divided by a as well. And you can understand easily here that if I separate these terms, ax squared upon a plus bx upon a plus c upon a, and the right hand side will be 0 because 0 upon a is still 0. So a, b, and c are constants, right? Okay, so in the next step, we will cancel out this out here and this out here. So what we get here, we get x squared is equal plus b upon a and within bracket, and then we can write here x plus c upon a equal to 0. Now we can transfer the c upon a on the right hand side on this side, right? So the next step again, we are going to get this is b upon a and x, and the right hand side will be equal to minus c upon a now. Okay, now thereafter the left hand side we need to make whole square. So this is a little bit tricky here, but not difficult, very easy. So what I'm going to do, you see here that I'm going to add a term here, which is, so first of all, writing these terms as such, and then I'm going to add here half of b upon a and a square of that, the whole square. And the right hand side will be then c upon a plus half b upon a, right? And then square of that. So what does that mean? That means that left hand side is nothing but simply x plus b upon 2a and then square equal to minus c upon a plus, and this can be written as b upon 2a again and the whole square here, right? Okay, so let's understand this part here a little bit. Right down here that why and how this entire portion of three terms is equal to x plus b upon 2a whole square. So let's use this formula here. You know that a plus b whole square is equal to a square plus b square plus twice of ab, right? So if I use in place of a plus b as x plus b upon 2a, right? And if I do the whole square here, then the first term is square, second term b upon 2a square, and then the third term, which is 2 into first term, and then the second term b upon 2a, right? Which is nothing but simply equal to, let's write down this again here. So that will be x square plus, this is going to be b upon 2a. And actually, if we write down this, the third term first, that would be better. So I'm just going to write down this term here actually. And this is actually, you can see here that this 2 and 2 will be cancelled out, this 2 and this 2, right? So what we get after that? After that, we get simply here b upon a, right? Bracket and x. And then this term, last term, which is b upon 2a, and then whole square. So basically we are getting here three terms, and let's compare these three terms with this equation here. So the first term here is this one, right? This is first term, and that first term is here. So let's define as first term. The second term here is this one, right? B upon a into x, and that second term is still here, and we can clearly see that second term. This is second term, right? And the third term is half b, this one here, right? And that third term is here, and we can clearly see this is third term. So all these three terms are nothing but simply x plus b upon 2a whole square, and that's what we have written here. x plus b upon 2a whole square is equal to minus c upon a plus b upon 2a whole square. Okay, so in this page, this is the next page, and I have written the same relation from the previous page, which is x plus b upon 2a whole square is equal to minus c upon a plus b upon 2a whole square. So we can take now taking under roots or square roots of both sides, taking a square root on both sides, right? So what we get? So we get on the left hand side simply as x plus b upon 2a, right? And on the right hand side, we get under root of this quantity, which is minus c upon a plus b upon 2a, and then whole square here. Let's put plus minus here. Now we can further solve it as this is going to be, we have to make this same denominator here. So what I'm going to do, I'm going to multiply it by 4a here, and let's multiply 4a here also. And the second term remains b square upon 4a square. I've just opened the bracket here. So this will be equal to plus minus and then under root again. The first term will become minus 4ac upon 4a square, and the second term will be b square upon 4a square, right? So now we have common denominators here, so we can simply write it as plus minus under root of, and this is going to be b square minus 4ac here over 4a square, which is nothing but simply, if you rewrite this part again here, then 1 plus minus, this is going to be 1 upon 2a. We can take this out actually, so it is better to write this way then. So simply under root in the upper part or the numerator part only, b square minus 4ac, and then divided by here simply by the whole as 2a, right? Now what I'm going to do, the left hand side we had x upon b upon 2a, x plus b upon 2a. So I'm going to transfer this part on the right hand side, so we get here x equal to minus b upon 2a, right? And plus minus, and then we have a line here, and then under root here b square minus 4ac, right, upon 2a. So finally what we get x equal to, now can see here the same denominators, so we can simply write it as minus b plus minus under root of b square minus 4ac over 2a, right? And this is your final value of x, and that is the root of this equation, which was written. I'm just writing here the equation we started: ax square plus bx plus c equal to 0, and the important condition was that a, b, c were constant and a is not equal to 0 because a is already coming here in denominator. So that's for the root of this equation, ax square plus bx plus c. For more similar videos, you can go to my YouTube channel, which is known as Education NIE. I hope you find this video useful. Thank you for your attention and thanks for watching.